All right, so this is part 2 of our video for creating a Stack Overflow clone. As I said last time, this is my existing website. The real major difference is that you can have a bounty for questions so that if somebody answers the question, then they get paid the bounty. So we are going to be rewriting this application. It's still going to be React on the front end, but I'm going to be using Ionic because I want the iOS and Material Design Android look and feels. As eventually I'm going to put a PWA version of these apps into each of the stores or submit them. And I would like them to look pretty much like any other iOS or Android app. So then on the back end, we are going to use something called Vert.x. We are also going to use Kotlin. And if you're not familiar with either of those, you can watch some of my previous videos. And the reason for that is simply because Node is not that performant. And I want much better performance, and Vertx is going to get me that. On top of that, I do like Kotlin, the language, and they have this multi-platform feature that will still allow me to reuse a decent amount of the code inside of my JavaScript because the multi-platform can emit out to JavaScript. So that's what we are going to do. And because this channel is a full stack channel, I didn't want to do like whatever it is, 3, 4, 5 videos straight of only client side stuff. So this second video will be focusing on getting the back end up and running at a base level. So as I said, we're going to use Kotlin. We're also going to use Gradle. And we're going to use the newer 4.0 version of Vertx, which is not production ready. But since I already have a working application, I'm not in any kind of a hurry. According to the team, 4.0 production should be released sometime this year. So just realize you're going to need the Vertx web package. You're going to need GraphQL because we're going to use that and tie into Apollo GraphQL client in the React side. We are using reactive Postgres SQL client because of its performance. If you didn't know, a lot of the server-side applications, if they're not performant, it's because they're using threaded or blocking code, which is what some of the older Java Spring server frameworks are still using. So that's why we are using reactive PostgreSQL, which is non-blocking. So we're going to use Kotlin coroutines, and this I believe is required to use the coroutines. We're also going to use config, and then later on, as we need, we will add any other dependencies. So if we go to our project, just confirm that the stuff that I just showed you is there, right? That's the language package for Vertx. On top of that, of course, you need the packages from JetBrains for Kotlin. This is Java compatibility on the STD. This is the core, coroutines core. And then this is interop with the JDK. So you want to make sure you have that. You want to be on a newer version of Kotlin. And again, it's going to take us a few months to build out this app, so I'm not in any hurry. So the first thing that I need on this server is I need a way to pass in configurations. On my existing Node app, this is my existing Node app, it's done by a .env file, and then you grab properties from that .env file like this. So I want to emulate something similar. So in the case of Vert.x, you can do basically the same thing using this package. Now this package will allow you to get your configs not only from a configuration file, like we have here, but it will also allow you to get it from environment variables, system properties, and a couple of other locations. We're just going to do the environment variable and these configuration files. And as you can see, I have a production file and a dev file. So we're going to use the environment variable to tell us which file to use. And the way to do that, actually before I show you that, let me also show you. So as I said, it's Vert.x, but it's Vert.x with Kotlin. So wherever we can, we're going to take advantage of some of the more idiomatic syntax in version 4.0 of Vert.x. And one of them is to use a coroutine vertical instead of an abstract vertical, which allows us to make suspend function calls, which is why these two guys are suspend calls, and also coroutine calls. So in order to do my dynamic file configuration scheme, I'm going to first create or get all of my environment variables. And then I'm going to add it and retrieve it. So what I'm doing here is I'm creating a store from all the environment variables. I'm creating a collection of different stores. I've only added the environment store for now, but I'm going to add the config store later, and I'll show you how to do that. And then I create this complete collection of all of the various variable properties, and then I take that and I get the JSON converted version or the text version of that data. So here, this is a suspend function, so I'm allowed to call it just like a synchronous function because this is also a suspend function. And then I can get any of my environment variables. And in this case, obviously, I'm just getting it by the variable name and I'm printing it out. So if this works, then we should see it on the terminal. So that's my current environment variable value. I'm in dev mode. So that's pretty straightforward. And as you can see, I call it up in here because start is now a suspend function. And as you can see, even though this is an asynchronous call, I'm calling it just like a synchronous call because of the way suspend works. So now I want to create a file store and this is the reason why I made this a var instead of a val, because I knew I was going to overwrite it. And then once I do that, I have to recreate the entire collection, but I've got to do one step, which is I need to give the path to my config file. And that path is going to be dev, or my environment. So now I said, hey, go to the path, the base path, and then look for my config file. That's going to be inside of resources. And then take this store, this new store, and add it on top of options, which again I made a var. Then I made the retriever also a var, and then I recreate the retriever. And then I re-get the JSON text. Now it has everything. So that if I print, all right, file is called JSON, or the extension is called JSON. All right, so as you can see, instances comes out. All right, so that's what the configuration system looks like. So we'll get rid of this. All right, so now we have set up our configuration. So like I said, it's getting all of the environment variables, and then it's doing a reset in order to additionally add the configuration file. So now that we've done this, we need to actually pass it to Vert.x. So the way that we do that is, first of all, I'm going to make this return the configuration, the sum total configuration. So then I'm going to create a a deployment options and pass it to the vertical. So now our HTTP vertical is going to get this set of configurations. And then if we go to our HTTP vertical, we can start passing these things, these values in from the config file. So I've already added the CORS enabler to allow the client URL into our HTTP vertical. And then this port is going to be replacing this. So then this is the config. This one is a little bit more complicated because it's it's an actual object that's coming back instead of just the string itself. So we have to actually I'll do this. It's an integer. So that compiles. Just for testing purposes, I'm going to put in just a simple response. Okay, so now we know it's working and our configs are coming in. So I'm going to add the Csrf security feature that's also part of Vert.x. There's actually a lot of packages for different functionality that you can use with Vert.x, but so this is a cross-site. Basically, it's a security measure that allows a private key for all of the requests that are coming in, so that the system can identify that nothing is being spoofed and the connections are actually coming in from a valid browser. So we're going to use config again, and then we're going to use our Csrf secret. This guy needs the vertical, the Vert.x, the main Vert.x instance passed in. So it rebuilt. I'm just gonna double check this. So that's it for configurations. All right, so I wanted to set up the authentication. And it's a pretty involved process, so I didn't want to just have a super long video of me typing a bunch of stuff. So I just got everything working and tested it, and I'll just go through the code with you. So to start, I have a little data access layer helper. It's going to be using the Kotlin singleton pattern, and basically I am having initialization of the connection to my Postgres database, which is the backend that I'm using, and it's going to go into the Vertx config, the one that we set up in the last video, and get all of these variables to set up the connection options. And once they're set up, it's going to create this client instance so that from a pool, it can get any available connection so that we don't run out of connections to the database and overload the database. So I am doing the same thing here with these two suspend function calls. I'm creating one that the query takes parameters and one that doesn't. And basically this is suspend function, so is this, and so is this. So I'm doing this so that I can have async calls that look synchronous. So this is my data access layer helper, so that I don't have to keep rewriting this code. And then what you need to do is you need to inherit from this auth provider class and override this authenticate function in order to be able to test the authentication on your routes. So as a test, I created an instance of the PG auth provider, and I'm actually running it here to do the test. But before I go through that, let me just show you what I'm doing here. So this auth provider's constructor is taking the Vert.x configs and the Vert.x instance, and ultimately it's going to go to the database, do a query, and get the user object. This is for initialization purposes of the DAL data access layer helper. So that's where I'm passing in these variables. So anyway, this overridden authenticate function takes the credentials, the username and the password, and then since it knows this is an async call, it will, whenever the call is finished, decide whether it failed, either because nothing came back or some other reason, or it succeeded. And if it succeeded, it needs to return an instance of this interface. So this is the user object representation. So I have overridden, inherited from, and then overridden that user interface for the stuff that I might need. Most of this stuff presently I'm not using, and I might end up not using it all. Like, I'm not entirely sure I need these authorities. Authorities are just logical permission groups. So logical groupings of sections of your application that you might want to distribute access. So this user could have access to administration and have access to home or whatever, and another user might not have access to administration, but they might have access to home, stuff like that. The principle is basically effectively the same thing as the user object, but in JSON format. And this I don't think I'm ever going to use, so I didn't overwrite it. So this authenticate method will handle the call to the database based upon that authentication query that I showed you. And then when it comes back, it's going to check if it was successful or not. Hopefully it was. Then the user object will be sent back via this result handler. So here, there's a couple of ways to do the authentication checks, but the way that I'm choosing to do it is just wherever there's a call on a certain path, I'm going to take, for test purposes, I'm hard coding it here, but later on, once I build out the GUI and I pass in the, I post back the username and the password, I'm going to take those from there, but for now I'm hard coding it. And then it gets sent to that authenticate function. Anything that I need to do after the fact is handled there. I just pass this for testing purposes. And that's it. So if we test this, we can see that the user principal does come back successfully. Now, this is really cool in part because if I go back to my PG Auth provider, you can see that I'm using bcrypt. And by bcrypt, I mean this guy right here, jbcrypt. And the reason why that's pretty cool is because, as I mentioned, my website is already existing. And the backend, including the insertions of passwords, was already done via JavaScript bcrypt. So without any kind of rehashing of the passwords that are existing in my current database. This is my users table. This is the passwords field. Without any rehashing, I'm just calling the Java version of bcrypt, and I'm basically doing the same call, which is called check pw instead of compare, and everything still works. So for example, if I were to mistype the password, let me see something just to make sure. Oh. So you can see that does work. So I was a little bit concerned about compatibility there, but we had no issues, and that's really cool. So in the next video, I'm going to be merging all of this authentication stuff with the GraphQL Java. And then I'm going to create a client-side login screen or modal in order to not hard code these values. Thanks.